Welcome to Ask and Learn.
We are going to find the critical numbers of the function h of t equal to 3 times t minus arcsine of t. So first we talk about the domain of this function. The domain of h is the values of t for which 3t and arcsine of t are defined. 3t is defined for every real number t, but the arcsine of t is defined only for numbers between -1 and 1, including those values. That is because we're looking, arcsine means the angle for which the sine is equal to the number t. So the number t can only be a value between -1 and 1 and can be either of these two values, -1 or 1. So it's a closed interval, -1, 1. That's the domain of h. And now we calculate the first derivative of h, and we get 3 minus 1 over square root of 1 minus t squared. This is the expression here for the derivative of the arcsine of t, the inverse of the sine function. And we remember the definition of critical number, which we are going to use here. So C in the domain of a function f is a critical number of the function if the derivative at c, the derivative of the function at the value c here, derivative at c does not exist, or it exists and its value is equal to 0. So this is definition of critical number of a function we are going to use. So the first thing we are to note here is that the values that can be critical numbers of a function are in the domain of the function, first of all. And that's the first condition. The second one is either that the derivative at that point does not exist or the derivative at that point is 0. So the only possible values that can be critical numbers are the values between -1 and 1, including -1 and 1. Now let's see this derivative here. And we have a square root of an expression here. And this expression is positive for t squared less than 1, and that for absolute value of t less than 1, that is t between -1 and 1. This means that the derivative of the arcsine, of the inverse of the sine function, is the interval -1, 1 without including the endpoints -1 and 1. So the derivative is defined for all values of t in this domain of the function except for the endpoints. And at those values, 1 and -1, the derivative does not exist because we have an expression that can't not be evaluated at all. So the values that we can conclude is that t equal +1 or -1 is in the domain of the function because they are the endpoints and they are included in the domain, and the derivative of h does not exist at these points. And so we use the definition, and we must say that 1 and -1 are critical numbers of the function h. This is because, again, I say it again, because these numbers, 1 and -1, are in the domain. Let's say here r is better. Okay, had to take this out for a moment. And here is better to say r, but because we are talking about 2 points here. Okay, so put it again. And so these points, -1 and 1, are in the domain of the function h, but, or besides that, the derivative at those numbers, 1 and -1, does not exist. Then, by definition, these two values, 1 and -1, must be critical numbers of h. So we have already these two critical numbers. Now we got to see if there are more than that. That is, points in the domain or values in the domain where the derivative is 0. So we got to state that equation here. Derivative equals 0 is the same as 3 minus 1 over square root of 1 minus t squared is 0, which is the same as 1 over square root of 1 minus t squared is 3, and that's the same as saying that square root of 1 minus t squared is 1/3, or the same as 1 minus t squared got to be 1/9. And here, to have the equivalence here, it's important to notice that t got to be between -1 and 1. But that's a requirement already set when we calculate the derivative. We can only consider values of t between -1 and 1, excluding, and 1 excluding -1. And for that reason, because t is in the open interval from -1 to 1, we can say that this equivalence here is true. So going that way, we can take the square root both sides because they are positive quantities. Okay. Now this is equivalent also to t squared equal 1 minus 1/9, and this is the same as t squared equal to 8/9, and so t got to be equal to more or less square root of 8 over 9, that is square root of 8, which is 2 square root of 2 over 3. And so t equal more or less 2 square root of 2 over 3 are critical numbers of h. But I haven't verified exactly that they are in the interval -1, 1, and I gotta do that. That is, know that 2 square root of 2 over 3 is about, if we calculate that number, it's about 0.94 28 28 0904 16. So the positive and negative value with this magnitude here is in the interval from -1 to 1. And so it's true that these are critical numbers because they are in the domain of the function and the derivative at those points is equal to 0. So this is the second part of the problem if you want. So in summary, function h has 4 critical numbers t equal more or less 1 and t equals more or less 2 square root of 2 over 3. And this is the final answer. And I recall that we have look at the domain of the function, we have calculated the derivative, and we saw that there are points where of the domain of the function that for those points the derivative does not exist, and so those 2 points, in this case -1 and 1, get to be considered critical numbers as a function. That's the part of derivative not existing. And the other part is derivative equals 0, and the points we found are both in the interval -1, 1, and so they are critical numbers of h also. In summary, we have 4 critical numbers of this function, the endpoints of the domain -1 and 1, where the derivative does not exist, and the numbers more or less 2 square root of 2 over 3, which are critical numbers because they are in the domain of the function and the derivative at those points is equal to 0.